Hi everyone, this is Alice Gao. In this video, I'm going to walk through an example of the variable elimination algorithm. Let's consider a portion of the home's network, consisting of burglary, earthquake, alarm, and Watson. I also modify the probability slightly. Our goal is to calculate the conditional probability of burglary given that the alarm is not going off. First, let's write down what we need to calculate using probabilities. We'll divide up the variables into three types. B is a query variable, A is the evidence variable, E and W are the hidden variables. To calculate the conditional probability of B given not A, it's sufficient to calculate the joint probability of B and not A. To do this, we can start by calculating the joint probability using the Bayesian network, and then sum out the hidden variables E and W. To make this more efficient, we can move the summations to the right until they only contain the variables being summed over. This final expression is what we're going to calculate using the variable elimination algorithm. Step 1. Define factors. We will define one factor for each node in the Bayesian network. There are 4 factors in total. To double check, we have one factor for B, one for E, one for A, and one for W. Step 2. Restrict factors. This step assigns the evidence variables to their observed values. For each evidence variable, we need to find all the factors that contain the variable. For each such factor, restrict the factors such that the evidence variable takes its observed value. For our example, the only evidence variable is A. A appears in 2 factors, F3 and F4. First, we'll restrict F3 to produce a new factor F5. Similarly, we'll restrict F4 to produce a new factor F6. Whenever we perform any operation, discard all the factors that we used and create a new factor to store the result. We'll use each factor exactly once in the variable elimination algorithm. After the restrict operations, we have a new list of factors containing F1, F2, F5, and F6. Step 3. Eliminate the hidden variables since they do not appear in the probability that we want to calculate. First, we need to choose an order of the hidden variables. For this example, let's eliminate W first and then E. For each hidden variable, we will do 2 things. First, find all the factors containing the hidden variable and multiply them together. Second, sum out the hidden variable from the product. Step 3.1. Only one factor contains W, so we do not have to multiply any factors. Next, sum out W from F6 to produce a new factor F7. Note that W was the only variable in F6, so F7 has no variable and contains a number. Next, let's eliminate the hidden variable E. E appears in 2 factors, F2 and F5. Let's multiply them together to get a new factor F8. Sum out E from F8 to get F9. This concludes step 3 on eliminating all the hidden variables. At this point, each remaining factor should contain at most the query variables. Whether we need to perform the next step, step 4, depends on the number of factors remaining. If there are multiple factors left, we need to multiply them together. For our example, we will multiply F1, F7, and F9 together to produce a new factor F10. If there's only one factor left, we can skip step 5 and continue to the normalization step. Step 5, our final step, is normalize. We'll normalize the final factor so that it represents a probability distribution. Normalizing the factor produces a new factor, F11. The final factor F11 is a distribution containing two probabilities. The probability of B is true given that A is false, and the probability that B is false given that A is false. This concludes our example of the variable elimination algorithm. Thank you very much for watching. I will see you in the next video. Bye for now.